So, just a quick sum up. Can anybody explain to us what that is asking you to do? What curve? So we would say an area under x squared from x equals 0 to 3. And it would look like that graphically, right? Is there a geometric shape that would help us solve that problem? No. So we have to do this one algebraically if you want the exact answer, right?
Yep.
Okay. So, being organized and using the right notation, we kind of stressed that this year. The first year was kind of a struggle with derivatives, but you got derivatives down pretty good notationally. Make sure you're doing this notation correct. Okay, so what is the antiderivative of x squared?
No.
Add 1 and divide, right?
Yep.
Evaluated from
0.
0 to 3.
Don't have to do plus 0.
Nope.
Not when you're evaluating on the result.
Went over that yesterday. The definite integral does not require the plus c.
What's that little line thing?
This means evaluate. So we have used this symbol now. It's gone. So we are going to now evaluate. And we have an answer, as long as it's correct, right?
So struggling.
Again, be prepared for both. Okay, we did not address yesterday how to deal with absolute value. Okay, so I want to talk to you about that. Okay, so what's the difference between something like this and something like this? Okay, the one on the right has no negative numbers. The one on the left can, keyword can, have negative numbers. So this one we can do algebraically very quickly now, hopefully. Just like I showed you, right? Antiderivative. Okay. I'm going to show you this graphically first, then I'm going to tackle the algebra. Okay? So, what's the y-intercept here? 3. And the slope? Negative 1.
No.
You have 0 to 5, right?
Yep.
Good? You graph a line, and then you just put boundaries on it. Okay, what's the area of this triangle? Half of 3 times, I'm hearing it, 3. 9 over 2.
Woohoo! That's 3.
What about this one? 2 times 2?
No.
You get nine for the
Okay, so we should get, when we add these up, we get 13 over 2.
I don't know why my brain is so
Right?
work now, dude.
Aren't you subtracting?
No, oh, hold on.
Whoa.
That's a negative area, right? So we need to do subtraction. And we get 5 over 2. Yes, okay, no, I just did the absolute value already.
Oh, so you can't, oh.
The absolute value doesn't have a negative, right?
Yeah, so you just.
Okay, so you have the answer for absolute value. You're welcome. Questions on that graphically?
No.
Senor.
Okay, absolute value.
Oh, so actually value is bouncing off the x-axis.
That's the first part, right? Positives. Can absolute value be negative? No. Look familiar?
Oh, yeah.
Okay, so you have an absolute value now. So that's one way to handle absolute values. Right?
I just feel like it's okay with puppies on it.
We already know this area is 9 over 2. Am I going too fast?
Caleb's just a little lost.
I know, because he wasn't here
Go back
yesterday.
to that one. How'd you get 5 over 2?
Yeah, I'm explaining it to you and you're not even listening.
4 over 2.
Okay, so keep in mind from yesterday, I told you, your math teachers have preached to you that area is never negative.
Yep.
Okay, so the area is not negative, but the position of it is. Anything below the x-axis is a negative position, so the area is negative 2 to denote where it actually sits. So you subtract it.
So that,
Okay, we know that this area is 5 over 2. No, goodness me.
It is not 5 over 2.
It's 2, right?
Yeah.
Now we add,
9 over 2.
because they're both positive, and we get 13 over 2 here.
I got that. Got that. It's 9 over 2 minus 5.
Yeah.
Okay. So that's a graphical solution technique for absolute values. Okay. Algebraic. Somebody lead me through that. Kellen Jensen.
3x minus x squared. And then you got
Evaluated from.
5 and
Okay. So 15 minus 25 over 2. Minus, what does the 0 give you? Okay. 5 over 2. Is that right?
Yes, sir.
Hey, look, our answers agree about that. Levi? You good?
Yeah, I'm good.
Pay attention. All right. How do we deal with absolute value algebraically? These match from 0 to 3, correct?
Yeah.
Okay, so the positive case is normal. Correct? How do I generate the function for this? 3 to 5. What do I put here? You're very close. You're thinking on the right track. It's the same function. We just have to do something to it. This gives you negatives.
You put the,
How do you get positives? Multiply by.
Negative.
It's not stupid.
yeah,
Right there. That will give you your positive numbers. Take the negative case, multiply it by negative. Gives you a positive, right? Negative
Yeah.
times a negative is a positive. This will make that this line. Okay, so this is the negative case. So in an absolute value integral, you have to split it where the function becomes a negative. So the positive case is always the same. The negative case you multiply by negative.
So why does the positive, oh, okay, it makes sense why the positive is 3 to 0. Never mind.
Is there a way to
Yeah, and
know?
you have your 0 to 3, 3 to 5. Okay, algebraically dealing with absolute value. Do I need to finish that?
Yes, please.
3x minus x squared over 2 from 0 to 3 plus. You can rewrite that if you would like as negative 3 plus x. It's easier. So negative 3x plus x squared over 2 from 3 to 5. If you need to, you can do that. Again, write everything out so that you don't mix your negatives up, because they do start flying around quite regularly with absolute value. And then you have some arithmetic, right? But you'll end up with the same answer.
So, you plug in that top number?
Top number gets plugged in minus the bottom number. Evaluate top minus bottom. Top minus bottom is a phrase you'll get very used to in this next 2-month period. Top minus bottom.
that's how long this is, this unit?
Well, chapter 5 and 6 is all integrals. No chapter 7. A little bit of chapter 9, like a day. Okay, so again, summary of algebraic, geometric integrals, and then how to deal with the absolute value. If you have any questions. Okay, I think there are, did I write all the problems down yesterday?
Yeah, you did.
Okay, so there are 4 or 6 more. New plus spiraling.
Yep.
Okay, we will talk about those tomorrow. Again, if you are really having trouble with this, you gotta come see me. We can nip that in the bud right now so that you aren't struggling the next 2 months. Okay.
Awesome.
Right.
About to give it to
Thanks for playing.